Hello and welcome to this talk. I'm going to do something I don't normally do, which is to give a caveat before the talk begins and say that if you are here to learn about process, you are in the wrong room. If you are here because you want to take a nap, that would work. When I came up with the title for this talk, I thought, how can I make it clear from just the title that it's not going to be a serious talk? And so I came up with the title. And a friend of mine came up to me earlier and he said, yeah, I stumbled into your talk. I didn't actually know that it was you presenting. I just wanted to learn about process, and then I saw the title of your talk and went to it. Okay, so maybe next time I would use this title instead, although maybe that just would make people think that I was really serious about process. Either way, let's get on with the talk. I first want to thank Stefan for asking me to talk to this group about process, because it's so important. I think that this conference benefits from a lot of talks about technology and a lot of talks about process itself, but not about the process of process. And that is what today's discussion is about. I want to talk about the topic of crystal methodology, which is, of course, the future of software development, process, effectiveness, and this is the presentation about it. I, of course, am a process methodologist. I have been known for being other things, but not this evening. So the first question you want to ask is probably why? Why should we implement important process in our organization? And the first part of this presentation will answer that exact question. The second question that might come up is, what is process? In which case, I might ask, why are you in this room? Nevertheless, I will attempt to answer that question with a description of many of the past and current and future trends that are so important in the process field. You might then ask, when can I implement this process? When should I implement it? I would say probably re-implementing it as often as possible is probably the right answer to that question, especially if you hire expensive consultants like me. You would then ask, well, how can I implement this? And of course, how much will it cost? If you need to ask the last question, maybe you can't afford my rates. In any case, I'm not going to answer these questions because that would cost. This is all free. So, of course, there are several reasons why process is so important, but the four primary reasons, which are clear to most people, are MDD, self, EBN, and MBH. I think it's pretty clear from the chart that MBH is by far the winner here, although self and EBN follow closely behind. MDD is a bit smaller, but still has significant standing in the reasons field. Now, it's important to look at not just the quantity of importance that these reasons have, but the trends over time. Now, MDD has had a fairly steady take over time, although it has dipped in the last couple of years. Self, on the other hand, had a rise in popularity a few years ago and then sort of hit a plateau and has been fairly steady since then. EBN came out of nowhere. It had nothing until just a couple of years ago and got significant traction, although obviously it couldn't come anywhere near MBH. So now let's actually describe, you probably don't need this description, but let's actually talk about what these acronyms stand for. MDD is, of course, metric-driven development. This is the idea that data is everything. It's a highly data-driven, model-based, quantitative, analytical approach that attempts to get as much data as possible and apply it to the problem in order to produce quality product. Because, of course, the quantity, the actual raw amount of information that you have, directly impacts the quality of the resulting product. I think this is most clearly illustrated with some charts. So here's one. You can see that the sheer quantity of the amount of stuff on the left-hand side has a direct relationship to the quality of the product on the right-hand side. You can also see here that there is, in fact, a direct proportional relationship between these two items. So clearly, the more data you have, the better your product gets. Now, of course, you could be asking, well, what kind of data could I get? There are so many different kinds of data. That's the best part about this approach to process, is that there's an infinite amount of data that you can get, collect, analyze, and chart. So let's take a look at some kinds. Now, business people might be concerned with something like this: how much money am I earning per developer? I personally find this sort of statistic sort of meaningless. I prefer to look for more esoteric data and try to draw my own conclusions from that data. But if this works for you, then that's certainly a place to start from. HR departments like to think about the morale of the company compared to, say, the perks involved. You know, can we look at the coffee and see how happy the people are and give them more drugs if they're not? Some people concerned about software development might look at some of the metrics of the code involved and, you know, look at this chart, for instance, and say, well, obviously there's too much code per white space character. And we've got to do something about that because we're not producing clean code. Now the data is getting a little bit more interesting because we can look at disparate factors such as the amount of coffee being drunk and the amount of beer being drunk and see how that relates to the lines of code, the actual amount of code being produced, and the number of bugs being produced. And then we can start to correlate data. I prefer an approach where you take as many kinds of data as possible and you aggregate them together into a holistic model from which you can start to derive more meaningful results. So, for instance, we can take a look at how hipsters might compare to greenhouse gases and left shoe wearing. And we can then chart this data, which may, from the outside, look unrelated, but once you actually put it onto a graph, it's obvious that you can start drawing some conclusion and making some real decisions based on it. First of all, you can look at the extreme outliers, which are interesting because they're so different from the rest of the data. It could be a bug in the data itself, but it could also be an indicator that there's something wrong with the inherent model. You could also look at the correlation trends and say, obviously, there's something going on in these regions where the numbers are so similar in data that's so completely and ridiculously unrelated. And then you can start creating projects around that data. So the second important reason is, of course, the self reason, which is somebody else's fault. In any project, big or small, things will go wrong. We know this. We're humans, and humans are stupid. We make dumb mistakes, and the most important thing about those mistakes is that when we make them, we don't want to be blamed for them. Especially if you are a highly paid consultant and they can fire you at any time. The important thing is to not catch the blame. Remember, don't blame the consultant, blame the process. So if you pick the appropriate process, you can always say, it wasn't me, it was obviously the process. So self, very important, gaining a lot of traction lately. EBN, I find the most fascinating here. It's the idea that you have typical schedules of typical engineers. So you start out with planning, of course, and then the product manager walks in and wants to talk about things, and then you have a design review, and you need to talk about the budget because, of course, there's money involved, and therefore you have to talk about it. You have a little bit of whining going on. You try to cram a little bit of coding in there right before your skip level meeting, and then you go off to lunch with your manager probably to have a one-on-one and set some long-term goals. You have some team building, possibly a team offsite, although those tend to take 2 to 3 weeks at a time. You have a test review and a spec review, of course. Every day you should have an all-hands with your entire department. You may have some suicidal tendencies that you want to ponder a little bit before writing a little more code. And then you want to consider your bugs, and then review the review. And all of this is before the end of the day when you go home and drink yourself to sleep and start again the following day. Now, the important thing to notice here is those 2 coding slots. Those are at the essence of EBN. That's the most critical and important part of the whole process, which is efficiency by necessity. I would put it to you that engineers work far better under pressure than they do otherwise. And therefore, the more pressure you can apply, the more constraints and the more limited time you give them, the better their code will be, because they don't really have a choice. And you can see that on the chart here, where the number of meetings directly correlates to the effectiveness of that engineer. MBH, of course, this one should be obvious to anybody working in the consulting field. The MDD process obviously takes time. There's infinite data out there that you have to collect. And then, of course, you need to make pretty charts about it. You need to analyze the data. You need to draw some conclusions. This results in more data that you want to collect, maybe some surveys, some feedback on the data itself, some meetings about the analysis. Time. EBN as well also takes a lot of time, just because of the sheer number of meetings that are required to achieve the goals of that process. And all of this results in more billable hours. So to wrap up this discussion about the reasons for process, you have to understand that software equals process. Without process, there would be more code, and obviously if there were more code, there would be more bugs. Once again, we can look at the data-driven approach and see that more lines of code means more bugs. So what we really need is more process so that there's less bugs. Now, at this point, you're probably saying, okay, these are really good reasons for us to implement process, but I still have no idea what he's talking about. So we may want to get an overview of some of the past and current and future trends of methodologies. So let's take a look. Traditionally, process was all about, this model of we make things in this certain way. First of all, the client says, well, here's what I want. They're probably wrong about that, and you'll have to correct them over time, maybe in version 2. Requirements are refined, of course, into a design spec, and then you implement that. And the code is produced, and then you test it for correctness, and then you package this thing up, and you ship it to the client. Now, you can take a look at this graphically. You have the client that gives you the requirements, and you go through the design, the code, and the test phase. And then if you don't pass, you iterate and you cycle around. But eventually you pass, and then you ship it to the client. And if you take a look, the client at the end of the process is happier than the client at the beginning, which is what you're after. So this sort of makes sense intuitively. This is kind of, I think, how all of us growing up pictured processes working. But it's so obviously wrong because it's so simple. It can't possibly be this simple. You need to have decision points in there. You need to have more and more details that need to be understood and iterated upon. And there's so many nuances and subtle bits about how projects actually work, especially people-driven projects, that a simple diagram like that simply doesn't capture it. But the worst thing is, I didn't see any bold highlights at all. Obviously, we need more of those. So there are lots of different processes that evolved over the years to address the problem that one was simply too simplistic to capture the reality of how we all work. So we'll take a look at some of those. First of all, there's the waterfall model, right? This is pretty much a representation of what we just saw. You have requirements, you have design, implementation, one step leads to another. We have a new methodology that's based on that, abbreviated FALL. It's also called the cliff model. Obviously, we have some users of this model. So we have the starting point that leads directly to the ending point. The starting point is also referred to as the harebrained idea. And then you have the middle part, which is called the leap. And then finally, we have the corpse. Another traditional process is called Scrum. It's based on short iterations and constant communication with the team. You have changing requirements. This is trying to address the real-world need where the client may change their mind along the way or refine things based on what they're seeing from the product. And so you do these short iteration cycles, these sprints constantly. There's the SCUM model that's based on this. Except the SCUM model is actually based on the individual. There are constant and rapid check-ins. So you're constantly writing the code, and then you're checking it in. And the whole idea with this process is that you expect problems to occur. And you expect this because you're looking for it. You want the problems to occur because that will flush out the scum in the process. What you're really looking for is bad developers to show themselves by checking in buggy code so that you can get rid of them. With scum, the idea is that scum floats on top of the water, so you just have to wait for it to get there, and then you skim it off. Agile programming, of course, closely related to Scrum. You have these small development cycles, you have changing requirements, very dynamic. So we have another model that's currently popular called fragile programming. So in agile programming, you really pay attention to what the client wants very closely, and these iteration cycles sort of work toward those changing goals. In fragile programming, you adhere strictly to what the client asked for. And every cycle, you write totally from scratch. So instead of refining the product over time as the client changes their mind slightly, instead you reach the end of the sprint and you say, well, now what do you want? You start over, you write totally from scratch, and you give them exactly what they asked for. Write totally from scratch, of course, is known as WTFs. And the advantage to this process is that you will end up with incredibly buggy code, but you get to point at the client and say, this is what you asked for. Rapid application development is all about prototyping, because in the real world of software development, we don't actually know a lot about how it's going to work until we get partway into the project. So this is a realization that what we really need to do is do good prototypes along the way, then throw out the prototypes and actually start the real product. So there's another process that's based on that called rapid application development. In this one, the prototype is the product. You write the code that you think might be there, and you just go ahead and check it in. This process is commonly used in academia, homework assignments, and every startup I've ever been involved with. There's object-oriented programming, of course. This is the idea that instead of rewriting projects from scratch every time we work on them, we can create these nice, ideal encapsulated modules that we can work with. So you can create a module for one project and then simply reuse it on another project because it was nicely encapsulated. It didn't have dependencies in other parts of that other project, right? You can just carry it along with you. There's another model called OOPS. This is the idea. It's based on the similar tenet, except you don't do quite all the work to get you to a reusable project. You end up with dependencies, and you try to reuse the object, and it doesn't quite work, and so you end up spending a lot of effort and money rewriting the entire thing from scratch every time, and then you say, oops. There's clean room software. This is about ending up with a certifiably correct product at the end of the process. Closely related to the clean your room process, which is the idea that all teenagers and children have, which is, why should I bother to clean my room? It's just going to get dirty again. The approach here is that it's important to focus solely on the features. Nobody wants to work on bugs, documentation, tests, all the tedious parts of software development if the code is simply going to change, and we're going to have to redo those things anyway. So let's work on the fun stuff instead. So pair programming has been important and heavily used for a few years. This is the idea that there's a team effort, so you have more than two eyes on the problem. So you've got two people. You've got the driver that's actually writing the code at that particular time, and then you have the observer or the navigator. There's a related process that's popular called O-pair programming. It's also a team effort. It's very closely related. On one side, you have the programmer that does all the work, and on the other side, you have what we call the au pair, who does everything else. Fetches coffee, cleans the desk, gets those little screensaver pad, the screen cleaner pads, and cleans the monitor, takes care of the employees, everything that you don't actually want to do. Now, occasionally, the au pair will chime in with actual ideas on the project because that person has been seeing the project evolve over time and probably has some opinions. At that point, they change roles and are then known as the backseat driver. And also at that point, the programmer also changes roles and refuses to pay any attention to them whatsoever, and they are known as the jerk. We have test-driven development, where it's all about the test. Testing first. You write the tests, And then by the time you write the code, you can run the tests on them and verify that your code is correct. Check it in, you're done. Related to that, we have testosterone-driven development. This one is all about the tests. In fact, it's also about the test frameworks that are required every time you write a test, the test suites that wrap up all the test frameworks that you're coming up with, and the new test scripting languages that are required as part of the process as well. But the most important part of this process, of course, are the consequences of screwing up. If there is a bug that's in your code that was not found by your test, then your tests are inadequate, and they take you out back and beat the crap out of you. More importantly, if they find a bug in your tests, they shoot you. There's domain-driven development, where you have a domain, you have experts in that domain, and they collaborate and communicate closely with the people that are actually familiar with the model. So this is the idea that you have people working on the technology, you have people with domain expertise, and they work very closely together to come up with this holistic product. The Italians came up with an interesting idea based on this, called domani-driven development, with the idea that it can wait. I'll get to it tomorrow. They actually intended to start with exactly the same idea with domains and models and close collaboration, but as far as I know, they just haven't gotten around to it yet. We have UML, of course. This is about visualizing these incredibly complex systems that we have, these object-oriented systems where all these things are related, and it's nice to get a mental model of how these things function together. There's a similar system based on that recently called crayons, where the point there is really more to make pretty pictures. The important tools here are crayons and finger paint. Construction paper is helpful, and paste. The idea with this process is not so much to visualize the complex system, but to give the marketing people something to do so that the engineers can get some work done. So we also have some completely new trends in methodologies. We'll take a look at a couple of those. There's downfall-driven development. This is the idea that sometimes companies are most productive when they're going rapidly out of business. They produce products, versions, new pricing plans, completely ridiculous business ideas at an incredible rate just to try to stay in business. They're just throwing them out in the market as fast as they can, just hoping that something sticks. It's a very productive part of the company's cycle. There's companies with bad morale that are leaving the company at the same time as this company is accelerating pace of product development and shipment. So the idea with this process is, can you maintain that very fine edge of that rapid development cycle without actually going out of business? And so far, nobody has. There is conference-driven development. This should be familiar to most of the speakers that come here. The idea here is that, oh my God, a conference is coming up. We need some demos. And we also need some slides. So we'll put these things together. We'll show some good stuff, and then you arrive at the conference, and the marketing people get this great idea. You know, we really like what we saw. That was very flashy. There's all this graphical stuff happening on the screen. What we really need is a product, and so they announce a product based on nothing. So then conference ends, some time passes, and then theoretically you wind up with a product at the end of that. Now you'll notice that product is grayed out because of course that doesn't happen because along the way another conference happens. So you iterate on these conference cycles. It's really a process of iteration. And then finally there's the process of HS. This, in my experience, is the most common process in use today in all companies across the world. It's hack and ship. And thank you for coming.